Welcome to a new lesson. Our topic of today is symmetry. In geometry, we have two main types of symmetry: line symmetry and rotational symmetry. Line symmetry is also known as reflectional symmetry. And if I were to define line symmetry, I could say that line symmetry, or the line of symmetry, is when there exists a line that passes through the center of a shape or object. I'm going to write figure. And divides it into identical halves. So there's going to be a line that passes through the center and divides it into identical halves. So let's look at these different shapes and determine if it has line symmetry, and if so, how many lines. So for this first shape or figure here, I have a letter A in a specific font. If I were to draw a line straight down the middle there, it does have a line of symmetry, but there is only one line of symmetry in this. If I look at the letter Z, I don't see a line of symmetry. If I were to fold it across horizontally, these two sides wouldn't match up. And if I went down vertically, of course it wouldn't match. So this does not have a line of symmetry. Looking at this shape, there are 6 sides. All of the sides look even. So there is a way to determine how many lines of symmetry I have. I have at least one straight down the center. I actually have another one going across horizontally. But there are actually a lot more. I have another one if I were to do it here at this angle. I have another actually right next to it. Another here, and lastly there. Now, it becomes difficult sometimes to count these because some people are inclined to go around and count like this, but then you wind up double dipping. So the best idea to do is to count as you draw. So I'm going to erase these and count again as I go. I'm going to start with each face. So these are my faces first, and then I'm going to go along the vertices. So 1, 2, 3 across each of the faces, then 4, 5, 6. So it does have line symmetry, and there are 6 lines of symmetry. Looking at this next shape, it is 4-sided, but those sides do not look the same length, nor do the angles all look the same in that figure. So because of that, it does not have any types of lines of symmetry. This next triangle I have here, again, I don't think it has symmetry, so that's going to be a no. Lastly, I have the word mom. If I were to draw a line straight down that O, it would have one line of symmetry here. Now, the other type is rotational symmetry. And when we talk about rotational symmetry, it means when an object is rotated about its own axis, that the object will look the same. So we're going to talk about what that means as we continue down, but first I want to talk about what a polygon is so that we can talk about these different polygons below. So a polygon is a many-sided figure. Any figure with a lot of sides is a polygon. Many-sided figure. Here we go. And a regular polygon is a polygon that has equal sides and equal angle measures. So all of the sides in the polygon are the same and all of the angle measures are the same. And when we talk about polygons, we classify them based on the number of sides. So this first figure that we have here with 3 sides is called a triangle. You guys already know that. Most of these shapes you might know the names are. Some others we might need refreshers for. But this is a triangle. And again, rotational symmetry means that there's an axis here in the center of your figure, so that when the triangle rotates around that axis, it will end up back in the same position as it was. So for example, if I rotated this around down here, I would have to go whatever that distance is to get down here for these vertices to match up. And to determine how many degrees that is, we're going to find what's called the minimum degree rotation. To find the minimum degree rotation, we're going to take 360 because it's going around in a circle, and we're going to divide it by what we call the order. Now, in this case, the order is just the number of sides. So when I do this math, I can take 360 degrees in a circle, divide it by 3 vertices that are going to be evenly spaced, and get 120. So what that means is that every 120 degrees, that triangle will map to itself. Now again, notice that I labeled that the minimum degree rotation. It's not the only degree because it can go 120, 240, 360, and so on. So let's look at the next figure here. This is a square if all of the sides and angles are the same. Again, this does have rotational symmetry because this is a regular polygon. And to determine the degree of rotational symmetry, the minimum degree of rotation, I'm going to take 360 and divide it by 4. So that means that when it rotates about its axis, it only has to go 90 degrees to match up with itself, instead of 120 like our triangle. Continuing on, here is a pentagon. Pentagons have 5 sides. If I take 360 and divide it by 5, I'll get 72. Again, 72 is not the only degree rotation, but it is the minimum. I can take 72 and multiply it by 2 to find the next degree rotation if I'd like. And I get 144. To that 144, if I wanted, I could add another 72. If I wanted to rotate it 3 times around, and I would get 216. See what I mean? So those are all the degree rotations. It's just that 72 is the minimum. All right, just a few more here. This is a 6-sided figure. The name for a 6-sided figure is a hexagon. Again, to find that minimum degree rotation, I'm taking 360, dividing it by 6. In this case, the minimum degree rotation is 60. The next one is an octagon. This is an 8-sided figure. Take 360 divided by 8 to get 45. And lastly, a 10-sided figure is called a decagon. And when I take 360 divided by its 10 sides, I get its minimum degree rotation is 36.